Hello, I'm Julian Spector from Green Tech Media, coming back to you live from Los Angeles. And we're now moving into Fireside Chat with Alejandro Schnakovsky, Director of Product Management at Wärtsilä. And so, we've heard from the research presentation earlier today about this trend towards more cabinet-based enclosures and different innovations that the storage industry is applying to drive down costs and improve performance and efficiency. And this is going to be a chance for us to really dig into that from someone who's working on it firsthand. So, Alejandro, how are you doing?
I'm doing great, Julian. How about you?
Oh, I'm good. Yeah, it's good to be back in my green suit. That I've been saving it for our next Green Tech Media conference, and it's been a long time. But well, appreciate you being here. I think to kick things off, we should sort of define the present moment, I think, in the evolution of storage integration and design. And can you talk about, how did we end up at this point in time where these cabinets, these more modular designs are flourishing? Where did we come from before? And, why are we moving in this new direction?
Absolutely. So I think the way, if we look back 10, 11, 12 years, roughly, let's say, if we want to kind of set that as a timeline for the modern energy storage industry, let's say, or battery-based energy storage. And what we see is that, let's say, first 5, 6 years, there was really a drive towards larger enclosure form factors. And the whole logic or the drivers behind that was essentially economies of scale. Ultimately, you're buying a shelter, it's going to cost X amount of dollars. The more batteries that you could fit inside, you're ultimately maximizing your dollars per kilowatt hours. And I think that, that sort of, we went from, custom metal enclosures, then let's say the form factor of the ISO shipping container started to emerge as a really, really, let's say, good alternative, initially as manned, let's say, enclosures. Then as the industry, let's say, evolved, we went into, let's say, unmanned 40, 45, 53 foot, ISO shipping containers. But I think we got to an inflection point relative to complexity of engineering those systems, okay? Safety concerns relative to the lack of ability to kind of segment your battery compartments inside such a large, let's say, form factor. And the third thing is that these large form factor enclosures, ultimately, they get built, there's kind of like a partial build where you're going to do, maybe your metal fabrication is at one facility, then the system integrator where the battery racks, your auxiliary cabinets, wiring, and so on comes in at one facility. And then there typically is a significant amount of site mobilization just to install HVACs, install battery modules, and so on. And I think that now, given the volume inflection point that we're hitting in the industry, the complexity of that chain made it such that the major system integrators started to look for form factors that would allow them to really manufacture at scale and kind of, taking from the playbook of the automotive industry. I would describe it that way. But I think that, primary concern was to really maximize the dollars per kilowatt hour. then with the realization of, well, this is really, we're just shifting some cost out onto the field and relative to the safety concerns. Now I think that the industry has hit a volume point that it's allowing certain system integrators to really build out high volume manufacturing facilities to, make these cabinets. And actually the costs relative to what we would, our cost, on a dollars per kilowatt hour to enclose batteries inside of a container are actually less today with these modular enclosures, which might seem a bit, counterintuitive. But where it comes from is that you no longer need to have these massive metal fabrication supply chain of a shipping container that's really pretty much centralized in China. But now you could really localize your production. So we are, we are really excited about, the possibilities that this is going to bring relative to project execution and localization of production as the industry continues to grow.
Okay, so there's a lot to dig into there. I guess one thought is there a theme here of kind of gaining a more holistic appreciation for the all-in cost of putting a project together? Like, instead of just thinking about the storage itself, it seems like the modular framework, you're looking more at how much time are my skilled laborers spending on the site? How much can I streamline and standardize in a factory? And just, taking a bigger picture look where you're actually saving money by going more cabinet based.
Absolutely. So, and I think it goes hand in hand as, we have gained more as the industry, let's say, have gained more traction. I think a few years ago, the focus was all, the batteries were relative to where the cost of batteries are today was, so much higher that I don't want to say that the cost to enclose and deploy was not taken into consideration, but in the value stack, it was not as significant of a percentage as it is today. The deals are pretty much being won today around, you obviously have to have access to a certain cost structure around your batteries, but the winners or losers are really being today determined based on cost to enclose, cost to deploy. And we now have this total cost of ownership that I think most system integrators are talking about. And that's really, let's say, the end-to-end, batteries, engineering, enclose, deployment, and then let's say, the O&M portion. So yeah, I think it's definitely been an evolution, and there are a lot of cost advantages because by having a common form factor, like a company like Wärtsilä, we operate in 125 countries around the world. We are, let's say, our revenues are pretty much evenly split international versus US based. That means that I have to have the ability to deploy at the same level of quality and predictability in my backyard versus, all countries around the world. And, with a large form factor enclosure, where you're always having to modify, customize, there's always room for improvement, it's really difficult to manage that globally with a high degree of quality. Whereas by standardizing the form factor, modularizing it, so it's also easy to build and configure systems, there's just, great advantage relative to, to scalability, which I think it's probably the next topic, concerning the industry. How do we scale profitably and maintaining a high degree of quality and safety?
Yeah, cabinets, but does it scale? So I think that's interesting what you pointed out about the declining battery cell costs factoring into this, because it reminds me of on the solar side of things where, modules start getting cheaper and cheaper, and then all of a sudden your soft costs and your racking becomes more of a factor in whether you win or lose deals. So just to get, so you were saying that the competitive like battlefronts where contracts are won or lost now, it's not so much about your battery costs, because like everyone's sourcing from these top tier manufacturers, but it's more on how nimbly you can integrate and kind of minimize the cost of deployment. Is that right?
Yeah,
I just wanted to.
No, absolutely. I mean, clearly, again, there are tiers. Okay, so I think you have like a tier one of suppliers, integrators, or vertically integrated companies, let's say like Tesla, that are playing at a certain cost point. And obviously, this is all around front of the meter, large scale, utility scale system. So I just want to be very clear so that there's not across the board generalization, because let's say residential CNI, that's completely different. But if we really talk about these, gigawatt hour projects that are being, let's say that are being offered, the players that are typically being shortlisted at that sense, they have, fairly similar cost structures relative to their access to, dollars per kilowatt hour on batteries and dollars per kilowatt relative to inverters. Okay. Now, where the differentiation now starts to come is, capacity to do that globally, meet schedules, and so on. What is now the dollars per kilowatt hour to safely enclose those batteries, and how many features? What's the performance of that, let's say cabinet in that sense? And that also, let's say ties up to the deployment speed in that sense. Now with these mega projects, cash flow is a concern. And again, it's just the natural evolution of every industry, where now your turn times and such become quite important. And again, having something like a modular cabinet where you can really transfer most of this work from the field and insource it into a manufacturing shop floor has just an incredible amount of value. Again, it's a playbook from other industries that have, let's say, have had to industrialize, infrastructural deployment.
Well, I think that's a great point, and I'm always interested in when you have so many, top-notch companies competing with effectively a similar, your product is a battery plant that does its job. How do you differentiate yourself, and and I guess going forward, do you see this becoming kind of commodified, however you might define that? Like, how do you maintain an edge in the competitive landscape if it seems like across the board we're seeing this movement to these tighter, more dense little cabinet designs?
Yeah, I really think that, in terms of commoditizing, I mean, the reality of the situation is that we are following, a cost curve down that is quite aggressively. And a lot of these concepts naturally will commoditize. 6 years ago, me and colleagues, we built up a business making, containers to, hold battery, to let's say, to package batteries in a, vendor agnostic way. And at the time that seemed, let's say, fairly revolutionary and noble. And today, pretty much, you can get yourself an engineered container, from several sources, different tiers, different levels of quality and performance. But the point is that, we have to recognize that there's a lot of smart people out there. The power industry and the power sector in general has designed, and innovate around similar challenges. So there's a lot of expertise. And, when you look at this trend of modularization, it's not different than when you look at like modularization of certain, let's say, even T&D components like pad mount switches, reclosers, and things like this. It used to be that, medium voltage, that if you needed certain amount of switching, you had to build a substation. And over time, companies like ABB, Siemens, Schneider created more modular solutions that I'm not trying to suggest that, you can have like a substation in a box, but for certain use cases, it really reduced the cost, that instead of having to have, a certain site, you could essentially just put something on a pole and it would serve as the sectionalizing point in your network. So storage it's going in that same, let's say, direction, where I think that these cabinets or this form factor, it's ultimately going to prove as a, let's say, superior solution. And I think what comes next is further or more integration, down to the battery string. That's clearly, let's say, the next step. If you think about it, Julian, I think, again, the definition of a system integrator in the ESS side, like 10 years ago, was like, okay, well, we kind of had the secret formula to cobble these systems together. Again, today, I think that knowledge exists in the utilities, IPPs, and so on. So the value of a system integrator has to continue to evolve so that we can, justify and prove our, our slice of the marketplace. And again, that's for the category overall. So we need to continue to innovate and add value.
Yeah, absolutely. I should say to the audience members, we want your questions. We have a few starting to come in. So thank you for that. Look for the Q&A tab and type those in. I've got a few more before we turn to those though. So what do you see as kind of niches where I guess we could call it old school now? That's, the container, the big container-based architecture. Is that going to persist in certain parts of the market, certain settings where it actually does retain some advantage over a cabinet design?
Yeah, I think we cannot look at these as like absolutes in that sense that all of a sudden, boom, we have this, how we went from CDs to DVDs or cassettes to CDs. I think, we're not quite there yet. And there's a couple of reasons. So, and again, I'll be very open and transparent and share with the audience, some of like the nitty gritty details. So it is very challenging. Once you go into these cabinet type systems, you have a very specific design, highly integrated, highly engineered manufacturing floor so that you can make, thousands of these things per year. That in and of itself requires kind of a level of coupling with the battery technology that it's just, it's not really necessary with a large container form factors. So, there's still room in the container form factor, and even us in Wärtsilä, we keep it in our portfolio because really two use cases. One, where customers specify certain battery technology. Again, it may or may not fit the cabinet. And then at that point, the larger form factor enclosure still has that level, let's say, of flexibility. The second part that we see is, there's been an evolution in the US, and obviously this conversation is very US centric, but when you go to other parts of the world, people are specifying containers because that's what they, let's say, expect. There's actually certain logistics advantages in terms of moving these things around. So, when you start to look at it from a global scale and you put together a cost model, you'll be surprised what comes out, out of that. And again, there's still certain projects for which a larger form factor still plays. But again, I think if you were to control for scale of a given market, meaning that then you can justify localization, that market will go to a cabinet form factor because again, the costs are, I don't want to say that are, let's say, half, but it's quite, it's close relative to the cost to enclose once you properly industrialize and scale your production.
Wow. Okay, that's big. So you're saying once you can have your factory serving a particular region and get that ramped up to scale, then for the amount of energy or storage, the cabinet's going to be about half the cost to put together as the whole container.
Yeah.
Wow.
Not the system, just the cost to enclose batteries. Let's put it that way.
Okay. That's quite interesting. But also that globally there are going to be these pockets where actually the containers still make sense. Because I think this past year we've just seen, you got Tesla, Fluence, Powin, you all just see everyone's rolling out their cabinet, but that's not to suggest that the other designs will like disappear.
I'll give you,
coexist.
I'll give you an example and kind of an analogy that I use a lot with customers. A lot of utilities view these large form factor enclosures kind of like an e-house. So a lot of the times you're just not deploying batteries. You're also deploying communications infrastructure. You might require some protection relays, data fault recorders and things like this. So, beyond the cabinets, you might still have the need for an additional shelter to hold some of these equipment. And when you do the math for a given size, it might be justifiable just to, switch to a large form factor enclosure and then integrate some of those components, inside your container. The other aspect too is when customers have a very specific or custom approach, to the integration of the batteries, and they want certain design features, let's say, built in. One of the big values of the cabinets, which again you can produce in series, is that we can finally have, let's say, stability and predictability around certification. So UL certifications for maintaining type test and things like this. That's really difficult with the larger form factor enclosure. So that's why, again, those lend themselves to a lot more for customization in that sense.
Yeah, and then it sounds like with the cabinets, you have to be so tightly engineered that there just isn't as much wiggle room to tweak things around and put something different. Yeah,
there really isn't. I mean, I describe it as, you kind of go to the, Honda Civic production line and, add a disco ball to the roof of the car. I mean, it's like it would be cool, but it's.
I think I saw a car like that going down Sunset the other day, but yeah, probably messes with the manufacturing flow.
Yeah, exactly correct. So again, I think horses for courses in that sense. Now, again, over time, I do think that it's going to become increasingly more difficult for the containerized form factor, to compete. One last point that I will add is that, one of the challenges with the larger form factor enclosures that we, let's say that we ran into is that you kind of have what I described as the Russian nesting doll problem. And bear with me for 1 second so that I describe that. With the way RFPs are written or the way customers envision, these battery power plants, it's, hey, I need this many megawatts, this many megawatt hours. And the size of the enclosure is really a function of, so those megawatts, megawatt hours are going to translate to certain number of battery strings, from manufacturer A, B, or Z. And then you essentially have to figure out how to enclose that. And there are two dimensions to that problem. There's a physical dimension of the form factor, but there's also a logic dimension around how you string those batteries together and connect them to an inverter. And I can tell you, it's a space optimization problem for which you can come up with a 37-foot container, 32-foot container that fully optimizes the enclosure, footprint for a given number of racks that you're carrying, let's say, on your project. That is really a problem that's totally eliminated with the modularization. Because with the modularization, you're ultimately having, let's say, a smaller battery bank per enclosure. So the additional cost of having like an extra enclosure that's not fully, the fill factor of the enclosure, it's not 100%. The costs are not so high to deploy an additional enclosure. Whereas if you have to deploy an additional 40 or 53-foot container, I mean, it's a huge amount of space, but B, if you need to deploy something like that to maybe deploy 2 or 3 racks, it kind of throws a wrench into the economic model of the project. And I'm sure a lot of people on the audience, they have a lot of fun with this, with this problem. I mean, honestly, our sales and proposals team, used to spend a lot of time with this. And once you go into this modularization, just makes this site level engineering and conceptualization quite rapid. And again, this is what we need in order to scale.
Yeah, well, there's like a bunch of audience questions coming in. So let's switch to like rapid fire.
Sure.
We'll just get through as many of these as we can. We got, okay, so is the cabinet-based solution more difficult to deploy in colder environments like Canada, for instance, compared to a container-based solution? Are there any sort of factors around climate that you have to look at?
Yeah, I think again the answer is it depends. So I think one of the items again around the large form factor enclosures is that typically the HVACs are custom. Like your heating and air conditioning system, it's custom development on a side-by-side basis. And you typically can have a little bit more flexibility relative to like sizing heat pumps or sizing heating elements within those HVACs. So once you start looking at extreme temperatures, especially extreme colder temperatures, it is true that you have a little bit more flexibility in that sense. Going to a more productized cabinet solution, you would need to have probably a specific version for extreme climates on both ranges of the spectrum, like anything minus 40, 45 C. You probably you're going to have a heating element that matches that application, because that would something that allows heating at minus 45 C, for example, would be grossly oversized for the needs of, let's say, Northern California. So there you do have some flexibility. Now, I do see that there are several suppliers that are actually engineering these cabinets with this in mind, both on the colder end of the spectrum as well as the higher end of the spectrum, to support temperatures of, let's say, 40 C, 45 C, even up to 50 C in that sense. So it is a bit of a challenge, but I think most of the integrators that are offering these types of systems are offering options at the extreme ranges of climate control.
Gotcha. Okay. And then how do the modular cabinets work in areas with land constraints? Like, can you actually get more density into a small acreage with the cabinets, or do the enclosures have the benefit there?
It really depends on the concept. Okay. And this is, I think, where if you study, study the different design, the different cabinet designs, there are a stark difference around, around the footprint that you have. I can only speak, let's say, for Wärtsilä in that sense. And I can tell you that relative to a 45 foot container, we can get about 30% more energy on a square footage base relative to a containerized base system. And again, that's huge. The way we're able to do this is by having this concept of rows that they can grow up to 16 of these cabinets. Whereas on a container, you typically have HVACs on both sides, and you need to have spacing around the enclosure, not just on the sides, but also on the front and back. Whereas with some of these modular enclosures, you can kind of like build them up in a row, and you end up, with that. Also, there are, we are working on concepts where you are actually able to stack, these enclosures up. And then at that point, again, even on the baseline, there's better space, utilization. If you're able to stack them, and then it's even better, of course.
Yeah. And then audience wants to know, how do you handle cooling in the cabinets and also fire suppression?
Sure. So, different suppliers have, again, different, methodologies for the thermal management system. There are solutions that are leveraging air-cooled systems. There are solutions that are leveraging, let's say, liquid-cooled systems. Pros and cons. It's, let's say, conduction versus convection, thermal, let's say, heat removal. Liquid cooling, it's about, from a sheer physics standpoint, it's about 25 to 30% more efficient. But you have a slightly more complex system because now you're having to have, cooling plates and piping and so on. So, I think the judge is, let's say, out still on that one. From a performance standpoint, you can build a system that runs, firing in all cylinders with either option. relative to, let's say, relative to fire suppression, actually, this is one of the areas where there is a stark difference, and the cooling methodology actually plays a role. A lot of us are familiar with the McMicken incident relative to the deflagration. One of the contributing factors of that is that when you have an air-cooled system, you obviously want to minimize your air leakage to make it as efficient as possible, which by definition entails that you kind of want to engineer as airtight of a space as possible. Unfortunately, that has a bit of the consequence that if you have a battery failure and you are you're releasing gases, well, the airtight environment is doing what it is supposed to, and you're accumulating those gases. Whereas with a liquid cooled system, by definition, you do not need to maintain an airtight environment. Granted that if you do proper humidity management and so on, but now we're getting into nitty-gritty details. The cabinets themselves, they can, they support the several, the similar methods for fire suppression, like the large form factor enclosures. So aerosol, foam, and clean agents and water are widely used across, Wärtsilä and some of our competitors, let's say, as well. But I think one of the key things to take into consideration around the cabinet trend is that the envelope is smaller. So in the event that you have a failure and catastrophic fire, you can really segment your battery bank into a smaller, you're essentially compromising smaller amount of energy capacity. And I think this ultimately is it's the beauty of it. I describe it, as kind of the let it burn philosophy relative to oil field transformers in the industry. Again, just trying to bring a parallel to our utility folks on IPPs, where they're familiar with this sort of let's say firefighting type methodology, and this is really a unique benefit of these cabinet form factors across the board.
Yeah, that's good to know. Okay, we'll have to wrap up momentarily. And so I think we might have to cut it off now, in fact. But I am really glad that we were able to cover so many of the nuts and bolts of that, and sort of where the competitive dynamics are at. And apologies to those other there are a bunch more questions because people are really excited about this topic. But hopefully we can discuss those in some of the later sessions, because right next after this, we're going into a kind of one-on-one networking. So if you want to head over to the swap card link on the community tab in the web platform here, we've got 20 minutes of these meetings you can have with other people. Also, come back later in the day. We've got the interactive session, and we can get more questions in there. And we'll reconvene at 3:15 Eastern for the new levels of installation and operational efficiency panel. But before we go, Alejandro, thank you so much for guiding us through this, pretty, I think, crucial transition in how the industry is putting storage together for these large scale plants, and love all the insights and transparency that you brought to that. So thanks for being here.
My pleasure. Thank you very much for the attention and for the opportunity. Thanks, Julian.
Awesome. And everybody have fun with your networking. See you later.
Bye.